Hello students, and you are welcome to this module of Home Tutors. We will be looking at the subject circle theorems in this module. I want you to follow me with rapt attention. I am going to make the subject quite easy for you to understand, and much more than that, I have arranged it in such a way, broken it down into modules that you don't have to stay to watch everything at once. You can listen to it module by module. When you're a bit tired, you take a break and then you come back for the next module. But by the time you are done through with this module of circle theorems, you will have solved all the questions in your new general mathematics, because I took a lot of questions to help you solve them, so that by the time you look at the different scenarios of questioning there are and know how to solve them, when you go to any external examinations, it is just about a change of numbers. Once you know the procedures in solving the problem, you'll be able to handle the particular numbers that you are given. The outline for this module is as follows. We will be looking at the revision of some very important definitions. Then we will look at Theorem 1, the definition of Theorem 1 and its proof. Then we will look at some worked examples based on Theorem 1. Then we look at Theorem 2 with its definition and its proof. We looked at worked examples based on Theorem 2. We look at Theorem 3, its definition and its proof. And then we look at examples based on Theorem 3. Theorem 4, definition and proof, examples. Theorem 5, definition and proof, examples. And then we look at solutions to all questions. This is good news for you. Solutions to all questions in your new general mathematics textbook on the subject of circle theorems. And then we also look at solutions to some past questions from JAMB and WAEC. By the time you go through this module, I'm sure you will be prepared to solve any question that comes your way on the subject of circle theorems. Now come along with me. Basic definitions. What does a circle mean? A circle is the locus of a line of length r about a fixed point. Watch what happens. I hope you can see the red line moving. That red line is what is called a radius. It has a length r. Its base is fixed at a point O, which is the center of the circle, and then the locus of its parts as it rotates about a fixed axis is what is called a circle. I hope you got that. A circle is the locus of a line of length r about a fixed point. Secondly, what are chords, arcs, and segments? The length of the rotating line, like I said earlier, is called radius of the circle. So, this line is the radius of the circle. Now, what is circumference? The circumference of a circle is the path that is traced by the rotating line. We saw the red line that was rotating earlier, and the path traced by this rotating line is what is called the circumference of the circle. These definitions are quite important as we go into the subject. You will do well to replay this program again and again until you really get this definition into your system and you know what they mean. So that later on, when I talk of arc, when I talk of chords, when I talk of segments, when I talk of circumference, quickly you can follow and understand what I'm talking about. What is a chord? A chord of a circle is a line that is joining any 2 points on its circumference. I hope you see now why it is important for you to have known the definition of circumference. A chord is a line that is joining any 2 points on its circumference. For example, this is a point on the circumference of the circle. This is another point on the circumference of the circle. The line joining these 2 points is called a chord. A chord is a line that is joining any 2 points on the circumference of the circle. That is another chord. A straight line joining 2 points on the circumference of this circle. A diameter of a circle is a chord, but then it's a special kind of chord. Like you can see, the diameter of a circle joins 2 points on the circumference of the circle, but at the same time, it is also drawn through the center of the circle. So, a diameter of a circle is a chord that is drawn through the center of that circle. That is also a diameter because it is a straight line joining 2 points on the circumference of the circle, and at the same time, it is drawn through the center of the circle. This is another diameter joining 2 points on the circumference of the circle and drawn through the center. However, while the diameter is a chord, not all chords are diameters. For example, this chord is not a diameter. Why? Because even though it is joining 2 points on the circumference of the circle, it is not drawn through the center. So take note of that difference between chords and the diameter. Not all chords are diameters, but all diameters are chords. What is an arc? An arc of a circle is a path along its circumference between 2 points. Note, this is point A on the circumference of the circle. This is point B on the circumference of the circle. Earlier we said the straight line joining these 2 points is known as a chord. But then you can have another path joining these straight lines, which is the path that goes along the circumference of the circle. So the path between 2 points along its circumference is what is called an arc. I hope now you see the difference between an arc and a chord. So the chord is a straight line joining the 2 points, but the arc is the path along the circumference joining the 2 points. Now, there are 2 possible paths between point A and B. Watch. Between point A and B, you can have this short path. This is an arc and it is called a minor arc. So, you have a minor arc AB, which is this short path along the circumference joining points A and B. Or, you can have the long path, which is called the major arc. This is the major arc A and B because it is the path along the circumference of the circle joining points A and B. Okay, now we want to look at segments. What is a segment of a circle? A segment of a circle is that part of the circle that is bounded by a chord and an arc. Remember, we already said a chord is a straight line that is joining 2 points on the circumference of the circle. We also said an arc is the journey between 2 points along the circumference of the circle. Now, the part of the circle that is bounded, enclosed by a chord and an arc is what is called a segment. That is another segment, a portion of the circle that is bound, enclosed by an arc and a chord. Another important area of review is this, that the sum of all angles in a triangle equals to 180. In the triangle you are seeing before you, angle A plus angle B plus angle C should sum up to 180 degrees. Also, there is another important rule that you should bear in mind. That is, that the exterior angle of a triangle equals to the sum of the opposite interior angles. To illustrate that, it means angle X equals to angle A plus angle B. The exterior angle of this triangle is angle X. It's equal to the sum of the opposite interior angles. X equals to A plus B. Also, this exterior angle, angle Y, will be equal to B plus C. And lastly, can you imagine where angle Z is? Angle Z should be somewhere on top here. And angle Z will be equals to A plus C. Note that one more time. The exterior angle of a triangle equals to the sum of the opposite interior angles. And also that the sum of all angles in a triangle equals to 180 degrees. These are useful revisions that we find quite needful in the course of solving problems regarding circle theorems. Now, another review point. When two straight lines cross each other, the vertically opposite angles are equal. When two straight lines cross each other, as shown on the screen, the vertically opposite angles are equal. That is, angle A equals to angle A and angle X equals to angle X. Also, the sum of angles on a straight line equals 180. What do I mean? Here is a straight line. The sum of angles on this straight line are A plus X because it comes this way. That is, A plus X must be equals to 180. And finally, the sum of all angles at a point equals to 360 degrees. That is, when you sum all the angles that revolves around this point of meeting of these two lines, all should sum to 360 degrees. A plus X plus A plus X must be equal to 360 degrees. More review points. When a straight line runs across two parallel lines as shown on the screen, angle X1 and X2 are called alternate angles. Where are they? X1 and X2 are called alternate angles, and usually alternate angles are equal. Alternate angles can be identified as Z angles. They are usually identified as Z angles. For example, you can draw a Z this way and tell yourself the angles at the corners are always equal. They are called alternate angles. Angles X2 and X3 are called corresponding angles. X2 and X3. Corresponding angles are identified as E angles. We call them E angles. For example, this is like half of letter E. When you have a letter E, and then the angles here and here are equal. Also, you can have an angle here and here. They will still be corresponding angles and they will be equal. Note that angles Y1 and Y2 are also alternate angles. Y1 and Y2 are also alternate angles because these are angles at the corner of a Z. But then, you don't just go about looking for three lines that form a Z. The point is this: before you can call them corresponding angle or alternate angle, there has to be an indication that the two lines are parallel. And in mathematics, you usually denote parallelism by arrows on those lines. So there is already an indication that these two lines are parallel. So long you have ascertained that the two lines are parallel, when another line runs through them, the angles at the corner of the Z shape that is formed by the system are called alternate angles, and the E angles that are formed are called corresponding angles. Also here you can still see what we discussed earlier, vertically opposite angles, when two straight lines cross each other. So at this point, X1 and X3 are equal. They are called vertically opposite angles. X1 and X2 are equal. They are called alternate angles. X2 and X3 are equal. They are called corresponding angles. Another point you need to remember is this, that in an isosceles triangle, the base angles are equal. What is an isosceles triangle? An isosceles triangle is a triangle that has two of its sides of equal length. It has two sides equal. As you can see on the screen, we have a triangle ABC where AB equals to BC in length. Therefore, the base angles denoted by angle A here, angle ACB, and angle CAB, these are the base angles and they are usually equal. That is a very important point you need to note, that when you have an isosceles triangle, the base angles are usually equal. Another point of note, in an equilateral triangle ABC with height BH, this is a very important point you need to note. This is an equilateral triangle ABC. What does an equilateral triangle mean? It means a triangle that has all of its sides equal. Now, if this triangle has a height BH, the point I want you to remember is this, that the point of intersection of all the lines bisecting the sides of the triangle into equal parts is at a distance 1/3 times BH from each of the sides. I will prove this in a later module in order to avoid distraction, because here I'm just trying to do a review of major laws you need to put in mind. So later in another module, I will deal with the proof of this, but now suffice it to just know it. Let's illustrate what I'm trying to say. For example, this is a line AA which bisects the line BC into two equal parts. What I mean is this. This line AA bisects this line BC into two equal parts, that is AC equals to AB. And now this is the line BB which bisects AC. This is AC into two equal parts. And this is the line CC which bisects AB into two equal parts. The point is this, at the meeting point of these three lines, we are saying that the distance OH equals to 1/3 times the distance BH. This is a very important property of equilateral triangles. And by the time you begin to do physics, you will be told that the center of gravity of an equilateral triangle is at a point 1/3 of its height. Another important point of review that you should take note of is what is usually called in mathematics the Pythagoras principle. The Pythagoras principle states that in a right angle triangle, the sides A, B, and C of a triangle are related by the equations C squared equals to A squared plus B squared. But note this, that this is applicable only in a right-angled triangle. Now, what is a right-angled triangle? A right-angled triangle is a triangle in which one of its angles is 90 degrees. A right-angled triangle is a triangle in which one of the angles is equal to 90 degrees. So, we usually identify this in mathematics by perpendicularity. You can see that the length B is perpendicular on the length A. So, this is an angle of 90. So, this is a right angle triangle. And so long this is a right angle triangle, this expression holds. The square of the hypotenuse equals the sum of the squares of the other two parts.